Hello everyone. So today we are going to implement a patrolling path for the helicopter. So you can see this spline. So the helicopter will keep going in a loop in this spline that we have defined. We can modify it if we want. So when we play the game, in this level we start playing here, and as we engage in the fight, the helicopter will also go over our heads in this path. And at the moment I haven't implemented any shooting from helicopter towards the players, but it just goes. Later on we will implement that too, and we can implement some interesting mechanisms like place some RPGs, and so player can take down the helicopter. So here is the demonstration. Let's stay over here until the helicopter comes, and of course we have to fight some bad guys with my green friends. Helicopter should be coming from this direction. See, it's coming. Have enough firepower to take down the helicopter. Okay, it should have exploded over there. Right, so that's what we are going to work on today. Right, so yesterday we worked on just ascending the helicopter and then moving to the right, or basically we implemented the function to say give a point that the helicopter should move next. That's what we worked on so far. So the next step is, so this is the preview. Next step is creating a path, like a spline path, that defines the path helicopter should take. So for that, let me open the helicopter blueprint. Right, and here let's go to the parent helicopter, which is this one. Here I'll add a spline component. So this, can we make this invisible? No. Okay, so let's use this spline component to define the path helicopter should follow. So I'll name this one, what should we call it? Patrol. Let's call it patrol path. And then for this helicopter, we need to compile this. Right, now here we have the spline component. So let me modify it. Patrol path. Let's lift it to a level like this. And let's define a path like this. If I go to the top view, I think it would be easier for me to lay the path. Yeah. Press Alt and drag. No, wait. Select the spline point, then press Alt and drag. So you can have a new path, a new point. Right. So it's not a perfect round path, but this should be enough. So it doesn't have to go in a exact circular path, but yeah. Now, so once the helicopter starts moving, this will also move. Wait, this one. See, that will also move. So for this helicopter, I assigned an AI controller. AI helicopter. So this one should get the path points. So for that, do I have any interfaces? Yeah, VPI helicopter. Okay. Here I'll add a function get patrol path, and it should return an array of points. So vector path points, let's call it. Now in the VP helicopter, let's implement that function get petrol path. So from the petrol path, get spline, we can access the number of spline points, and then before return anything, we can run a for loop. First index is 0, last index is number of spline points minus 1. So using this for loop, we can access all the spline points. So again, from the spline point, get location at spline point in world space. So this is the point index. Then let's have a local variable path points. This has to be a array. Shall we promote to logit variable points? Okay, now we can get the points at, should we use add unique? Yeah. And add all these points. After adding them, we can return it. So we should get these points into the AI controller at the beginning. So when the helicopter is moving, it wouldn't matter if the spline is moving. So because the spline is attached to the helicopter. Right, now in the begin play, here we can get the control point. We already have a reference. get spline point. So get patrol path and promote to variable path points. Right. So at the moment we only need to make the helicopter fly in a circular path continuously, in a loop continuously. So we can do something like this. Not of this anymore. We can get the location and let's promote this to a variable. Let's call it point index. So we are going to loop through this array. Get the point and call helicopter move as the move target. Let's give the same acceptance radius. Let's say 500. That should be enough. And once the target is reached, I can increment the point index. Then if the point index is larger than not large, point index is greater or equal to the length or last index. Yeah, if we can access the last index, we can check if it is larger. Right. So that means we are going to exceed the number of path points. So what we can do is set, if this is true, we should set point index to 0 and then reiterate. Like this. If it is false, we don't need to set to 0. We can simply reiterate. Okay. Right. This should work. Let's see. Oh, one more thing. We can try this. When the helicopter starts, we can detach the spline so that we can visually see the path and see if the helicopter is taking the path correctly. For that, in the begin play, where is the begin play? Here. I can get the patrol path called detach from component. Keep world. Keep world. Everything keep world. So it will not move with the helicopter. So we have some reference to check if the helicopter is moving correctly. It is moving, but the rotation rate of the helicopter seems not enough. Let's just check if it completes the loop. No, wait. What can we do about the rotation? Here, this is the rate of the change of yaw. So if I make it 1, it will move. It will rotate faster. And one more thing, I think I should try to align it if the locate target is away from the current location somewhat. Because when it gets closer to the locate target and the helicopter location, it tends to change rapidly. So we can calculate the distance, and check if it is larger than, let's say, 500. Only if we should try to rotate. But without using a brush, we can do a select float here. If yes, 1, otherwise 0. Right, now let's check. Okay, it is working, but it doesn't feel like the helicopter is going in a smooth path. Well, it's obvious because we only used the points. So what we can do is instead of giving the points, giving only the spline points, we can give points along a set of points along the spline. How should we do it? Let's break this for now, and again get a reference to the patrol path, get the length, and then we can get location at location at distance along spline. Right, let's promote this to a local variable. Let's call this, what should we call it? Just distance. Right, distance. And as long as this distance is less than the length. Let's have a branch, so we can make sure we are not trying to access some point that does not exist. If this is true, we can get this value, add to the point. Then increment this distance with, let's say, 500. So distance and iterate. Right. At the end, if this becomes false, that means we have exceeded the length, so we can return the points. Alright. Now let's see what happens. Okay, it is working. Wait, why is it going step by step? Because this delay is too much, so we have to have a smaller delay. And also the helicopter was not turning, so because the distance gap is 500 here, and also we use this condition, so maybe not 500, let's reduce it 200, otherwise the helicopter will not have enough time to turn. Wait, another thing before we proceed. Here we used acceptance radius as 500, which I'm not sure, because the gap also 500, so we need to use something lower. Looks like it's working. Yeah, that's better. Let's see if complete the loop. Also, we do need to have some tilting of helicopter forward and to sides according to the moment. We will add those behaviors later on. First, let's get this to follow the path. Oh, what happened there? Alright, it's working. Okay, so here is the first level, the level 1 we worked on, where the player starts from here and we can fight our way through over here, and the helicopter is placed here. So now I'm gonna play the game and we should see the helicopter going around the level as we play. Started. See, the helicopter is coming. Maybe we can play some RPGs and allow player to take down the helicopter, and we can implement helicopter shooting at the player also. So yeah, we can implement a lot of interesting mechanisms. Okay, so yeah, I'm gonna stop this episode right here. Thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.